Hi everyone, this is an example where we're going to prove that these two triangles are similar, and once we've proven that, we are also going to calculate the two unknown sides, and that is side B that we have there and side D, the one that we have there. So the first step will be to prove that these two triangles are similar. Now, bearing in mind we have two conditions for similarity. Let me just write it here in pencil. The first one is SSS. That is side, side, side. It means that all the corresponding sides are in the same proportion. Not exactly the same, that is for congruency. They are in the same proportion, that is for similarity. Okay, and it's very important that it must be the corresponding sides. Then the other one that we have is AAA. That's the other condition for similarity. So let's say number 1, number 2. And number 2 is AAA. So it's angle, angle, angle. It means all the corresponding angles are exactly the same. Okay. So we must now first start to think, which one are we going to use? SSS or AAA? Now, what you'll see if you want to use SSS, that's corresponding sides. First, we see that this side corresponds to that side. Both sides are known, so that's good. But we need another situation where two of the corresponding sides are known. Now, this side corresponds to this side, but there we have an unknown, so that's a problem. And this side corresponds to this side, but there we have an unknown, so it's another problem. So we can't use the side, side, side condition, because only one pair of corresponding sides are known. Now the question is, can we use AAA, angle, 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 to say that all the corresponding angles are the same? And the reason is we can, because two pairs of corresponding angles are known. These two, and then this one and that one. Okay, they are the same. So what can we say? So I just want to make this clear that using one arc here and one arc here means these two angles are the same, and using two arcs there means these two angles are the same. Okay, so first when we're going to prove, let me just write here, prove similarity. So first we need to say what is the same. If we want to use the angle, 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 we need to say which angles are the same. So first we're going to say angle C is equal to angle D. So angle C is equal to angle D. And we're going to say that it's given, right? Because it's given to us in the figures. Now we can also say angle B is equal to angle F, because they are corresponding angles and they are the same. So angle B is equal to angle F. It's also given to us. Now the question comes in, is angle A equal to angle E? Now it will be, and the reason is because if two angles of a triangle are given, it means the third angle will be equal to 180 degrees minus this angle minus that angle. Now, if these two corresponding angles are the same, it means the third angle must also be the same for both, because it's the third angle in a triangle. Okay, so we'll say angle A is equal to angle E, and let's just say that the reason here is that it's the third angle of a triangle. And let's just say sum of angles in triangle, let's just say equals 180 degrees. So that is good enough reason to say that angle A is equal to angle E. Okay, so now we've proven similarity. So we can say, therefore, triangle ABC is similar. Now the symbol that we use for similarity is 3 vertical lines like that. Congruency, it's flipped around, right? To triangle, and now remember that the order is extremely important here. If we say ABC, so we start at that one, we need to also start at the corresponding vertex, which is E. So we'll have to say E, and then from A we go to B, so from E we go to F, and then D. Okay, and then you have to provide your reason in brackets, and it will be angle, angle, angle. So now we've proven that they are similar. Okay, now the second step is to calculate what is B and what is D. So if we know they are similar, then it means that this first condition will also be true. Okay, so now we can say that the corresponding sides must also be in the same proportion. So what I'm going to do is I'm going to say the thing is, if we compare the two corresponding sides, so this is how I'm going to do it. We go from 16 to that one, which is 8. What are we doing? So if we move from the bigger triangle to the smaller triangle, we are dividing with 2. Can you see that? 16 divided with 2 gives us 8. That is if we move from the bigger triangle to the smaller triangle. If we move from the smaller triangle to the bigger triangle, what are we doing? To get from 8 to 16, we are multiplying with 2. Can you see that? So 2 is like your scale factor. You're either going to divide or multiply with 2, depending on if you're going from your bigger to your smaller triangle or from your smaller to your bigger triangle. Okay, so let's first look at D. The corresponding side is 6. So we want to go from 6 to D to calculate what D will be. So if we move from the bigger to the smaller, we divide with 2. So we divide with 2, so what will D be? 6 divided with 2, that will give us 3. Okay, and then we also need to calculate B, and the corresponding side is the 6. So to get from the 6 to the B, we're moving from the smaller to the bigger, so we need to multiply with 2. So it will be 6 multiplied with 2, that will give us 12. Okay, hope that makes sense, guys. Have fun.